Let's look at the second question. A particle P moves along the x-axis. At time t seconds, the displacement of P from the origin O is given by x is equal so and so. Find the velocity of P when t is equals to 3. Now what is given here? X. What is x? It is displacement. Okay, it is a function of t. Okay, function of t meaning if we plug in the value of t, we will get displacement, and we have to find velocity. So we know if we differentiate displacement in terms of time, we get velocity. Writing the x here and here are the same thing. And if we differentiate velocity in terms of time, we get acceleration. So before we can find the velocity of P at times t is equals to 3, we have to find the velocity, general equation of velocity of P. So d dt of x is equals to d dt of t to the power 4 minus 13.5 t plus 12. So we know d dx of x to the power n is equals to n x to the power n minus 1. So if we replace x by t, d dt of t to the power n is equals to n t to the power minus 1. We are going to apply the same formula here. So 4t to the power n minus 1, which is 4 minus 1 is equals to 3, minus 13.5 into t to the power 1 minus 1, t to the power 0, which is 1. I'm not writing it, and the constant becomes 0. So this is our velocity. Now that we know the velocity of P at any given time, we can just plug in t is equals to 3 to find the velocity at t is equals to 3. So v of 3 is equals to 4 into 3 cube minus 13.5. 3 cube into 4 minus 13.5, 94.5, and the unit is meter per second. So this is our velocity. Find the value of t of for which p is instantaneously at rest. At rest meaning velocity is 0. Now we know the velocity is at any given time is 4t cube minus 13.5. Now for our case, we want to find the value of t when v is equals to 0. So we just plug in this equation into our calculator, or we can solve it manually. So 4t cube minus 13.5, if it comes to this side, it becomes 13.5 t cube is equals to 13.5 divided by 4, and if I cube root on both sides, I get this. Now value of t is equals to cube root of 13.5 divided by 4, 1.5. So that means at t is equals to 1.5 seconds, the object P will come to a rest. Now the last question says find the acceleration in meter per second squares of P when t is equals to 2. Again, we have to find the general equation of A and then plug in the value of t into that equation. So let's do that. We know v is equals to 4t cube minus 13.5 from question A. Now if we differentiate v, 4t cube minus 13.5, so we get 3 4s are 12, t squared minus 0, so I'm not writing 0, and if we differentiate v in terms of t, we get a. So this is our equation. Now we need the acceleration when t is equals to 2, so we will just plug in 2 here. So a is equals to 12 times 2 squared, 12 times 4, which is 48, and then unit is meter per second square. This is our answer.